Hello, it's Keith here, and this is lesson 9 of the SuckHunt series of my Z80 programming tutorials. You can see SuckHunt running up there, and we're going to be looking at the last part of the multi-platform code. Today we're looking at the code that starts up the level, basically defines the initial sprite settings, and does a few things relating to the progressive levels as the game gets more difficult, and also the levels will alternate the direction of the scrolling, and it's the level initialization that handles that kind of thing. Okay, let's go over to our code and let's take a look. Okay, so we're looking at the multi-platform file here again. You can see SuckHunt multi-platform here, and we're going to be starting from the init level section, which is the start of the initialization. This is run at the start of the game at every new level. So basically when a level ends or when the game starts, this is executed. And the first thing we do is we fade the screen out using the generic fade out routine here, and that will effectively fade out. Now if we just start a game here, just so we can see what we're talking about here. So this is what you will be seeing, you get that night sort of message there, and then the level starts here, and that's what this is doing. This is setting up all of the sprites you can see on the screen here. So after we've faded out, we will make the level sound. This is just the sound of a new level starting. This is to tell the user that if they were mid gameplay and the new level started, that's happened. So just a nice sound effect there. And this is of course using our Chibi sound sequencer. So that just is a little sequence of simple beeps, and then what we do is we clear all of the sprite data. Now this is generally a good thing to do if you're writing a game, even if you think that you're filling all of the data area with new data. It's best to clear out any old data just in case you're wrong, because it's going to save you a heck of a lot of debugging time later on if you are wrong. So I would suggest just wiping out any areas of data before you start using them, so that you know everything's in a consistent position when you start up. And then we're going to be defining the sprites in RAM from our templates. And so what we're doing here is we are pointing to our definition, which is the template, and then the RAM, which is the destination. And this is partially because we're starting a new level, and it's partially because the game might be running on a system that has RAM and ROM. So we're copying from an unmodifiable area, the definition, to a modifiable area that starts off as blank, and we've wiped it to be sure that it's blank, and that will be the RAM on a system like the Master System. So that's why we're doing that. So we are defining the power-up, and the power-up here refers to the power-up that we can collect. For example, this gun here you can see going across the screen is a collectible power-up, so that's the one we're defining here. We're then defining another item, which is the gun, and that is the gun on the heads-up display, and you can see that here. That's the currently used gun by the player. So that's why we've got two, and what we're doing here is we are then going to alter the gun to select the object that is currently the default weapon. So we are taking the address of the gun object we've just defined, the gun number the current player has. We're then adding the first sprite used by the guns. I think maybe it's sprite 5, I can't quite remember, but that's now the gun number. We're then updating the sprite number accordingly by updating that to A, and then we're running define sprite IY, which takes the object being pointed to and it updates the other variables from the sprite number. That's the width and height of the sprite, and also the memory address of the sprite in memory where appropriate. So that's what we're doing there. Here we're defining a background object, the mountain. Now there's just one mountain used, and it's used repeatedly to define all of the mountains on the screen. If we just start the game up here again, I will just show you what I mean. So basically what we've got is we've got a strip of mountains here, but what we're actually doing is these never move, they're constant positions, so we just have one object, and we repeatedly use it to draw a line, and that when the screen is cleared, and we just use it once, so there's only a single item there, even though it looks like there's lots of mountains. Next we've got the moon object here. That's a simple sprite, but it has a special purpose. You can see it moves across the screen, and when it gets to the end of the screen, we've reached the end of a level. So the moon we will see later on again. And then we've got a sequence of cloud objects here. We are just defining them. We've got B is the count of the objects, so we define a sequence, we define sprites. And then what we're going to do is we're going to give them a random X position using this set sprite random N, which will set a object, in this case the X position, to a random value between D and E. So we're giving them an X position, and then we're giving them a Y position, and we're giving them a random depth that is appropriate to their position. Now in the case of the clouds, we're going to put them somewhere up the top of the screen in this kind of area here, and we're going to give them random depths, so they might be in the foreground or in the background, as well as random heights. And this is what this set sprite random depth does, and it gives them a correct depth and movement speed so that we get some appropriate perspective of our sprites, and that's what we're doing there. So that cloud routine here will define our clouds. We've then got grass and rocks, which are very similar here, and again we're just going to make sure that if we've got two objects at the bottom of the screen, for example, we're going to want them to move with appropriate perspective so that the object that appears in the foreground moves faster than the object that appears in the background, because otherwise if an object is high up and moving faster than an object low down, well, that's going to appear that it's in the foreground, and that wouldn't be very sensible if it's on the bottom of the screen, because it's supposed to be an object on the floor of our game level. So that's what this set sprites random depth does. It's actually setting the Y and Z simultaneously, and it matches them so that the object feels like it's got a proper 3D depth and movement. Okay, so that's the objects that are sort of generic quantities for every level. What we're going to do next is we're going to set up the level according to the level list here. So we define the first 16 levels, and we define the objects and enemies that are on them, and that's so that each level has a progressive difficulty, and there's a bit of a sequence. When we get to the 17th level though, we loop back around and we start from 0 again, but we do a few other things to make the level more difficult, like increasing the amount of hits the enemies take. But this gives the game a bit of a sort of a wave feel, where every 16 levels will get progressively harder, but then it will ease up a little bit and get progressively harder again for the next 16. Now each level will have a combination of 4 kinds of object: the basic bat, bat 1, gobby bat, bat 2, the Chibico character, and the Corona character. Now the Chibico character is basically the boss, and the Corona is a bit of an obstacle that gets in our way, just as a bit of a sort of sidekick of the boss, maybe we could call it that. And each level definition will have a count of each of these kinds of objects. So we've got 3 basic bats on the first level, 0 gobby bats, 0 Chibicos, obviously, because it's the boss, and 0 Chibi Coronas. And then you'll see as the levels progress, these numbers will increase. Now, after the 4 enemy kinds, we have 2 of the variables, and these are the movement speed of the moon and the game speed itself. Now, the moon speed is how many of the ticks the moon moves. So as this gets higher, the moon will actually move slower, and then the game speed is how many ticks the game will update, and as this gets lower, the game speed will become faster. So basically we can increase the speed of the game, as in the enemies moving, and we can slow down the moon to make the levels longer, and this means as the game progresses the levels can get harder. So this is a very easy level, and this is one of the last levels. So you can see by changing the values in these movement speeds, we can change the game speed. And as I say, although we've only defined 16, we actually alter things with some overrides by calculating using the top 4 bits of the level number, and this is the unpredefined part, because as I say, the bottom 4 bits are the looping 0 to 15 levels. So here we are getting the definition, we're calculating the level number, taking the bottom 4 bits, multiplying that by 2, and using that as an offset to the level list. And what we're doing there is we are just selecting the address of the level definition. One of these level definitions is being loaded in, and then we've got a pointer to the actual data of the level definition, which is what we're going to use. So that's what we've done here, and that's what we've calculated, and we've stored that in IX. And then what we're doing is we're loading the level sequence, which is just a list of the kinds of enemy in a level. So this is the order that they are shown in this list here. So that's what we're doing here. We're loading in the address of the enemy type and the count of the enemy type from the level definition, and using define sprites to define that many of that enemy, and define sprites can support a 0 for nothing. So that's what we're doing. Then what we're doing is we've got some so-called bonus enemies, and these are based on the top 4 bits. So these are the parts that are making the levels more difficult from level 16 onwards. So depending on a few of these bits, we're shifting these bits around and basically adding a couple of extra enemies of each of the type, the Coronas, the basic bat, and the gobby bat, according to the higher level bits. So we're doing that. We don't add any extra Chibico because the Chibico is the boss, and there's only really one Chibico as far as the game world is concerned. So that's why we don't add any extras of that character. We're then setting the game speed. We're loading in 2 bytes there, but again, based on the top bits of the level number, we are actually shifting the moon speed, making the moon slower, effectively making the levels longer, and adding zeros to the top of the game speed, effectively making the enemies of the game move faster. So that's what we're doing there. Now, what we're going to do next is we're going to define the time that the enemies spawn, because we've defined all of these enemies, but we don't want them to all appear at the start of the level. Now, as I said before, a dead object won't respawn until its life reaches 0. Now, the life is actually the time till we spawn if the object is set as dead. So what we're doing here is we are setting the life to a random number here between 4 and C using the set sprites random in, and that will just give them all a random life, and that means they'll appear on the screen at different times at the start of the level. Now what we're going to do is we're going to initialize the scroll direction. Now this is basically alternate levels, scroll in alternate directions, and we have a way that we do this. Now let's just go over to our blackboard here, which is here we go. So if we imagine that this is our screen of our game here, basically we've got some objects on the screen. We've got things like our moon, we've got the rocks on the ground, the clouds, and things like that. We've got maybe some grass here, that's some grass, and all of these are going to be moving in a particular direction based on the level. Now on level 1 maybe they go that way, but then on level 2 we're going to want to flip things around, and what we do is we flip the scroll direction of the objects. So we're now effectively scrolling in the opposite direction. Now the other thing we need is we need an initial position. Now if the objects are going this way, then when a new object is created, it will want to be created here. But if it's going in the opposite direction, then we would want the new object to appear on the opposite side of the screen. So we're going to potentially flip our objects, and we're also going to have a differing start position, and that's what we're doing here. So what we've got here is we've got the screen edge spawn pos, and this is for the new objects, and so this is initially at the far left, and then what we're doing is we're taking the level number, the bottom bit, and if that's not going to change, then we jump all the way down here. But if we want to change the object direction, and so what we're going to do is we're going to go through each object and we're going to flip the movement to direction here. Now the bats and things all appear at random positions anyway, so we don't really need to flip those, but what we do need to flip is the position of the moon. So we're taking the X-pos of the moon and we're subtracting the screen width, and then we're storing the new moon position just here. So that will flip the moon to the opposite side of the screen. What we're then finally doing is we're setting the new minimum position where the new objects will spawn, and that's going to be updated there, and we'll be using that when a object like the power-ups has left the screen and needs to come back. So that's what we're doing there. Now we're now basically ready to start the level. So what we're doing is on the master system, we're defining the game tiles. We've got the title screen tiles, the font tiles, but we've also got the game tiles, which are the level graphics. So we're loading those in here because we don't have enough memory to load them all. And then what we're doing is we are locating a text cursor onto the screen, and we're printing the night number and the level number in decimal there. And then we are just going to fade in because we've drawn everything on our screen. We've got a simple delay, and then we fade out, and then we return, and the level will actually start. So there we go. Now, just as an added bonus, we're going to look at the pause routine. Just very simple, but it's the last thing in this file. So the pause routine is just a delay. It delays for BC, but it needed to slow things down an awful lot. So it also sort of delays for the count of A, which it sets to 255. Very crude delay here. But while it's pausing, it also updates the sound sequence. Now, the actual playing of music is done by the interrupt handler. This is just updating the pitches that should be played during that interrupt handler. So, as I say, a very, very crude pause, but that is the last part of this file. And there we go. Now, as I always say, if you want, you can go to my website, you can download SuckHunt, both the compiled game and also the source code. And as I say in all of my tutorials, you're welcome to use the source code in any way you can, even if you want to make some kind of commercial project out of it. I have a hunch you can't, because I don't think there's really any commercial potential in a game of that standard, but if you somehow manage it, then all the best to you. If you want to support my content though, you can buy my book. It's called Learn Multi-Platform Assembly with Chibi Akamas. It's available on Amazon now. It covers Z80, 6502, 68000, 8086 and ARM, as I'm sure you know, because I always mention it, because I have to fund doing all of this work somehow. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.